Welcome to Algebra 2, Semester 1, Unit 2 Notes. This is Day 1, Identifying Shapes of the Graphs video. On this, it says to do the parent graph on the attached worksheets by plugging in the domain values into the given equations and calculating the range. So you'll find those attached sheets at the back of your packet. The first one is the linear transformation activity sheet, and there you can see the grid. So our equation is y equals x, so you're simply plugging in the x values. If y equals x, then for every x value y is the same, and that brings us to these values. Now realize that your point is -3, -3. So we'd come over to -3, down to -3, and plot it as so. Pause the video, go ahead and plot all those points. I do ask that, if at all possible, that you extend your graphs clear across the grid. That gives us a good picture of what that behavior of that graph really is. Let's answer these questions quickly. What shape would you describe this graph as? A straight line. What is the domain and the range of this equation? Well, the domain, that's your limitations on your x values. So if you go along this x-axis, are there any limitations where there's not going to be a graph? And there's not, so the domain is all real numbers. The range is the y values. Going along the y-axis, is there any point at which there would not be a graph extending out? There is not, and so that's all real numbers. The reason this is called a parent function is because that's the simplest form of this graph. There's no numbers in there to adjust it in any way. The next page is an absolute value activity sheet. And again, we're going to plug these values in for x. So if we plug in -3, what is the absolute value of -3? Remember, absolute value means distance from 0. -3 is 3 units from 0. -2 is 2 units from 0. -1 is 1 unit from 0. 0 is 0 units from 0. 1 is 1 unit. 2 is 2 units. And 3 is 3 units. Please pause the video. Go ahead and graph this on your graph. Okay, looking at the absolute value graph, we see that having those absolute value lines, that's the only change from our last equation, causes this to become a V-shaped graph. The domain doesn't have any restrictions going left or right. You can go forever that way, so the domain is still all real numbers. However, the range does have restrictions. There is no graph down here in the negatives. The only graph is from 0 up. So we say in the range that the y values are greater than or equal to 0. And this is called an absolute value parent function because there's no numbers causing any transformations in that equation. That's the simplest form of an absolute value equation. The next one in your notes is the Quadratic Transformation activity page. Again, we're going to plug in the x values. -3 squared. -3 times -3 is +9. -2 times -2, +4. -1 times -1, +1. 0 times 0, 0. 1 times 1 is 1. 2 times 2 is 4. And 3 times 3 is 9. Pause the video and go ahead and graph those points. Whoops. And we see that that graph is a U shape. The domain has no restrictions because that U continues to spread out. So going along the domain line, if it's going out forever and ever that way and forever and ever that way, there will eventually be all the x values covered. The range, however, there is no graph down in the negatives again. So the range is y is greater than or equal to 0. This is called the parent function because there are no numbers causing that graph to transform. You'll see what transformations look like soon. The last graph tonight that you need to do is the x cubed. What I want you to focus on with the quadratic is that 2 is actually a representation of y equals x to the n when n is even. That's the typical behavior that we'll see, is that the ends go in the same direction on an even polynomial graph. And with the cubic graph, I want you to focus on it being y equals x to the n when n equals odd. We'll see the same general type of a shape, whether it's to the third, the fifth, the seventh, whatever it might be. So now we plug these in, -3 to the third power. That's -3 times -3 times -3, which is -27. Now a +3 times +3 times +3 would be a +27. -2 times -2 times -2 is -8. 2 times 2 times 2 is 8. -1 times -1 times -1 is -1. 1 times 1 times 1 is 1. 0 times 0 times 0 is 0. So pause the video and go ahead and graph those. So we say that that's an S shape. The domain is all real numbers because it does spread out as it goes up. The range is all real numbers. There's no restrictions on either of those. This is called the parent function because there's no transformations occurring, no numbers added into that equation. Okay, in class tomorrow, you will fill out these notes with a partner, and we'll talk about those notes. You'll fill out the domain and ranges for all of those, and then we're going to have some activities to do in class. So good job on the homework tonight.